Hello everyone, New York Games here, back with another video for the live coding series of remaking Getaway Shootout. Getaway Shootout is a game I've made in Unity. Check out the first video in the series for more information on that and what the series is about. In the last video, we finished doing the player input system, and we got it to just a rough state where we can get the players to have separate input. And for this video, I think it's a good time to now do the camera movement. So a separate camera for each player, and the camera basically follows each player. Before we get started on that, I did make some changes from previous video. Some of them that I was mentioning at the end of last video. So if I just go over to changelog, so the first change was just to add the gamepad input. I haven't tested the gamepad input yet, but it should be working for players 3 and more. The other thing I added was actually a fix for the player collision system. In the last video, I noticed that sometimes the players would not auto balance, and this was an issue because the player was not registering it as in contact. So the issue from this was actually what I was a little concerned about previously, is using this on collision enter and exit. Basically, you'd get into a state where it wouldn't call on collision enter, so it was never in contact. So the fix for this, at least for now, is just to use on collision stay and setting in contact to true there. And then you can't see this in the code, but in the fixed update, we always just then set in contact to false. So basically, we're resetting in contact every frame, and then only setting it to true every frame if there's a continuous collision. And that's just the Unity function for that. So that's the fix for right now. I might change it up in the future. Jumping back, the other change that I've made just before this video is actually adding just a template map for us to use. This will just make it easier for players to test around jumping and such. So I just added a map. The one thing to note is the map is using a parallax system, and I'll maybe get to that later in the series, but basically it just means the background is moving at a different speed, causing kind of this parallax effect. So that was one of the scripts I added to the game to have that effect. Also, the background is now using a different sprite layer. It's or sorting layer. It's using the background layer for background, and then I also added a foreground layer for foreground sprites. Those are small changes. One other change that I added just before this video is adding a camera manager script. So as I was saying in the other video, the previous video, it is possible to use the Unity built-in split screen option. And one second. Okay, sorry for the interruption. But as I was saying, you can use the Unity split screen option here, which is their split screen, which you can just enable it with a click. But as I was saying in a previous video, I don't like how combined everything is. It seems like this player input manager is just handling a lot itself, and the camera doesn't really seem related as much. But if this works for your project, definitely use it. It would be a lot easier to get up and running. But so what I did instead is just kind of create my own separate camera manager, and that's what we'll be using to create cameras in the Getaway Shootout game, and also manage the split screen. So I think that's going to be the first thing to do, is to get that implemented into our game. So I'm going to jump right into the scripts. And I'm going to navigate to the game manager, because this is where we are handling all the player creation, and I think that's a good spot for setting up the camera. So one thing to do here is to let's see, create the cameras, or at least tell the camera manager to create it. So I'm just going to temporarily have a reference to this camera manager. This is the class that I made, and I'll get into how to use it right now. And I'm just going to call it camera manager. And let's see, after we create the players is when we want to create the cameras. So I'm going to do another function down here and call it create cameras. And I'm just going to call it up here as well. So create cameras. So we want to use the camera manager to create the cameras, and I actually forgot exactly what I called it. Let me actually just jump to the camera script. So I had it a function called initialize. That's going to be how we initialize the amount of cameras. So initialize, and then pass in the amount of cameras that we want to initialize to. And this is just actually going to be the number of players that we have. So right now we're temporarily storing it up here as num players, and I'm just going to pass that in. And that should be good right now. Let's just see what that does in our scene. So jumping back here, we have this now variable called camera manager, and we need to set that up. So I'm going to actually create a camera manager. I'm doing it on a separate object. You could do it on the scripts object, but the cameras are going to be under this object, so I think it's just nice to have it separate. And I'm going to add the camera manager script. So this is the script that I created, and how I set this up is that all it needs is a camera object, and then there's the option to make all the screens equal for split screen. So I actually went ahead and created a camera object already. So I'm just going to drag this into the slot right here, and this was just in my prefabs. So that should be good. That would be all set up now. And I'm just going to now reference the camera manager here. Okay, so that should be all fine. Let's now test it. One thing before I'm going to test, I'm actually going to get rid of the main camera, since all the cameras are going to be created at runtime for each player. And let's see if it actually does that. Okay, so it looks like it has created 2 cameras, since that we have set here the number of players to 2. And yeah, each player should have an associated camera. Let's see. So now I'm going to get to this next problem, but yeah, everything looks like it's working so far. But the first problem now I want to face is something happening right now is with the parallax. So since we have 2 separate cameras, parallax only works with 1 camera, since the parallax is just based off the shift distance of the camera. And when you have 2 in the game, it has to reference 1 camera as the main point. So the other camera on the right side of here is going to get affected by the first camera. And that's what we don't want. We want each camera to have kind of its own parallax layer. And so the solution I came up with was actually with the scripts I imported. I'll show you exactly where it is. I just put it in the map scripts. So I have this parallax script, that's what's on each background object. And I made a script called parallax manager. And this script, I'll open up quick. This script is responsible for handling multiple cameras, and will duplicate basically all the parallax layers for you and handle that. So I'm going to put this into our scene here. So I'm going to add a parallax manager, And we don't have to worry about setting the cameras because we'll do that in code. But the only other setting here is the base camera parallax layer. And we'll need to, you don't need to do anything, but one thing that is nice, since I set it default to 14, is to actually create those layers up here, and I'll show you what I mean. So layer 14 here is going to be associated with the first player's camera, layer 15 the second player's camera, 16, 17, and so on. I'm just going to create the first two, so player 1 and player 2. Actually, I'm going to name these camera 1 and camera 2. But however many players you want to support, you just keep adding them in respect below the base layer, which was 14 in my case. So that's good. That's setting up the parallax manager. The last thing that we need to do is actually initialize this parallax manager. And to do that, I'm going to jump back into our scripts and set that when we create the cameras. So in this initialize function, we get an array of cameras back. So I'm just going to store that quick. Cameras, and call it cameras. So now with this cameras, I want to pass this into the parallax manager. So I'm just going to go, since it's on the same object, parallax manager, so get component parallax manager, and then I forget exactly what it was called. Let me see. I guess we just set the cameras directly, which is fine, but maybe in the future I'll make a method for that. But cameras equals cameras. Okay, so that should be initializing this parallax layer fine. Now let's just check to see if it's fixing that issue I was talking about before with two of the same parallaxes. Okay, so I'm going to move the first camera, and it looks like it's not moving the right side, which is exactly what we want. We don't want it affecting the other camera. Now I'm going to move the second camera, and same thing, it's not affecting the first player, and the parallax looks fine there. So that's just a quick implementation of parallax with multiple cameras. And if you want these scripts, you can definitely check the GitHub to just download them yourself and use it in your own project. So we have created the cameras. I'm just going to jump back into game quick. The next thing I'd want to achieve is to actually follow the player. Right now, the cameras don't move at all. It's both of them will just stay in place. So I think the next goal here is to actually follow the player. So to do that, I'm going to create a script, and I'm going to create it in the camera folder, and I'm going to call it camera follow, since it's going to be just following a transform in our scene. So I'm going to navigate to this camera follow script, and we can actually get rid of most of this template code. And the one thing, the main thing it's going to have is a public transform, and this we'll call it target. So this is going to be the transform or the game object that we're continuously following throughout the scene. And the only other variable I'll have will be a float, and I'll call this the lerp speed, and maybe default it to 5, and this will be a setting we can just play around with, and that should be good for right now. Now it actually will be a really easy script. So the main thing that we want to do is just follow the target. So all we have to do for that is to update it every frame. And the common practice to do in Unity is actually do it on late updates. And there are reasons for this. Honestly, I don't really know the exact reasons, but basically, you have update all the transforms just on the update loop, and then now you have the late update, which is where all the transforms have been applied. So I'm assuming this is the place that the transforms are finalized, and that's why it's better to do it here. So that's what I'm going to be doing, and what all we want to do is just set the position of this camera follow object to follow the target. So you could just do what the code's recommending, is just to have it equal the target position, but that will be way too snappy. It will just directly always follow it. And I kind of want it to be lerping, and when I say lerp, I want it to kind of follow behind and smoothly follow the player. So what I'm going to do instead is called Unity's vector3 .lerp function. And lerp, if you don't know what that really means, it just means you are having a starting value. This is the first value. So in this case, we're using vectors, but it could be floats if you're using math.float or math.lerp. But yeah, in our case, we're using vectors. So you have a from vector, and then a to vector, and then you have a float t, which is just the time, which is basically saying 0, you're at the from vector, and 1, you're at the to vector, and any value in between, you want to just lerp between that, or you just want to smoothly translate between those two. So to call this function, I'm going to do something like this. I'm going to have our from vector just to be the transform.position, and then our to vector is where we want to go. So this is actually going to be the target.position. But before that, I'm actually just going to store it in a temporary variable, target position. And the reason for this is that we don't want the z component of it. So I'm actually going to go target position.x, target position.y, and then instead of target position.z, we want to keep the camera's z position. So we'll just do transform.position.z. So jumping back to here, we just want the target, go to the target position. And for the t value, well, you could do multiple things here. If we put in 1, this would always just return the target position and be the same as that previous code I showed you, where it's just setting it to target position. 0, nothing would happen, but we just want to continuously inch closer and closer. So one method to do that is just to do the time since the last update, which is just time.delta time. And then we'll multiply it by our lerp speed. And that should be good enough to follow the target. So let's jump back into Unity and see if this is working. So I'm going to go to our camera prefab that I created before the video, and add this component to it, which is the camera follow. And right now there's no target, but we'll get into that later. I just want to see if this is going to be working. And I'm just going to set these targets temporarily. So for that first camera, I want it to be the first player. Second camera, I want it to be the other player. Okay, so that seems like it is working. There was throwing errors when there was nothing assigned. We'll add a little check for that. But that seems like it is working. It's following the camera. But unfortunately, right now, it does seem very jittery. And it might not show up on the YouTube video, but the movement is looking very jittery, which is something that we don't want. And I believe this is actually an issue with how we interpolate the physics. So I'm just going to test it quick with a test here. So there's also fixed, let's see, what's it called? Fixed, well, okay, I'm just going to do it on fixed update because I believe it's an issue with following a physics object. And I'll just double check if that is correct. Again, we'll have to assign these manually. So then it is much smoother because it's on the fixed update, which is where the physics is being applied. So I'll just temporarily have that as the solution. But what I did in my game is actually have it on the late update. And there's a setting in Unity to change to interpolate so it doesn't have this jitter effect. But for right now, we're just going to keep it like that. One thing I'm going to refactor this a little bit, and I'm just going to move this into a function. And basically, I just want to check if the target is null or not null, only do the follow function. So yeah, it looks good. That'll avoid the errors if we don't set the target. Next, well, when I was looking in the game, it'd be nice if our players, if the camera was offset just a little bit. So if we go to set one of the players again, in the actual Getaway Shootout game, it seems like there's a little offset with the camera follow, and that'd be kind of nice to have here as well. So I'm going to do a public vector2 and call it this offset. And in this target position, when we create the target position, I'm just going to pass in and add the offset here. So offset.x and offset.y. That should be working now. And then before I test that, I actually just want to make this a little easier to work with. So every time we create the camera, well, what we could do is loop through all the cameras that got created, and basically with like some sort of for loop like this, and set and get component of the camera movement or camera follow and set the target that way. I'll just do that for right now, I guess. And I'll show you, we'll actually make this better in just a little bit. So I just realized we're not storing all the players in the scene. So before I do this, I need to actually store every player that gets created in our create player script. So I'm going to do a private player, and this is going to be just a players array. And this will store all the players that we create, because right now we're not storing them. They're just created in the scene. We could find them later, but it's just nice and handy to keep this tracked. So every time we create a player, we want to set it here to player, and then get component, the player component. So this is good. That will work, but currently right now we haven't initialized this array yet. So this would give us an out of bounds, which is what we don't want. So I'm just going to initialize this quick right here. So players equals new players, num players. Again, this is just temporarily in the game manager script, but it's fine there. Let's see, we haven't finished this yet. So I'm just going to jump back into this camera file, and I'm just going to say, hey, we want to follow the ith player, so that's just players.i.transform, and that should set each camera follow to the player that we want to follow. Let's see if we have, oh, accidentally removed that. So let's test if this is working now. No, it hasn't worked. Okay, so just a slight mistake here. So we're currently getting the component on our own object. That's not what we want. We want to get the component on the camera like that. And that should be more what we want. Okay, now let's test if this is working. Okay, so it automatically set for both of those players. And to test out the offset, I'm just going to offset it a little bit, and that seems like it works great as well. I'm just going to set a default offset to our game camera. So jumping into the prefab, I'm going to set a default offset, and I think in the actual Getaway shooter code it's an offset of 2. So I'm going to set that there. Okay, so the next thing, basically at this point, the camera movement is working great, but I'm just gonna change it up a little bit to make it easier to work with in the future. And the first thing I'm going to do is to actually jump back into our scripts, and instead of working directly with this camera follow script, I'm gonna create another script to manage it and to handle finding the player, handle when this game ends. So basically it's just gonna be like a camera controller. And we could do it all in just this one camera follow script, but I find it nicer if we just keep things separate and keep the purpose of this script basically just to follow a single transform. And I think that's gonna be nicer and more organized that way. So I'm going to create then the script I was talking about, and this is going to be called, we could call it game camera controller. Yeah, names might change in the future, but we'll call it that for now. And I'm just going to assign before I forget, assign the script to this controller. So I'm going to assign game camera controller to our game camera prefab up here. And yeah, that'd be fine just to set that. And then now jump into the code. So the purpose of this game camera controller is just I wanted to handle all the finding the player, and also just changing the camera target and doing that all, and not having the game manager to do that. So the first thing I'm going to do here is, well, first I need to communicate with the game manager. So I'm going to do a find object of type game manager. So this is just going to find the main game manager. In the future, I'll probably make this a singleton, so we don't have to do this find object of type every time. But for right now, it's fine. And all we want to do right now with this is just get the player from the game manager. So I'm going to jump to the game manager. Right now, players are stored in a private array. We want to make this accessible for any script that wants to get a player. So I'm going to create a function player, get player, and then just pass in a player ID. So we just want to return the player that the script wants. So players, player ID. So now we have this function here. We can call it get player. And now this is an interesting time of how do we know which player to follow? Is it player 0, player 1, and so forth? And this was actually something I did a little behind the screen or scenes before the video started is working with this camera split screen setup. And actually, I'm just going to comment this out for right now and show you in the scene exactly. The way that the player can get, or the camera can get the player it's following is actually each camera is created with this camera info script. This is something I created while I was doing this split screen setup. And if I debug the information, all the camera info has right now is just a camera ID. And we're going to associate each camera ID just to the player ID. So all we need to do is just to get this camera info script and use that to get the player ID. So jumping back here, I'm going to do that here. So int player ID equals get component, and we want to use that camera info script that I made and get player or get camera ID. So this is going to be player ID we're trying to follow, and I'm going to set that here. And so now we're getting the player, the correct player. I'm going to store it as a transform. Like that. And one thing, forget, this is not the exact, so Unity updated this. I think it's find object first, or find first object by type. It's just a new way to call find object by type, and I think it's supposed to be faster or just renamed. And so we get this player object now. Now all we want to do is to tell the camera follow script we want to track this player, and this can simply be done by just getting the component of the camera follow and setting the target transform like that. So saving that, I'm going to remove this, and I'm going to jump back to Game Manager here. And basically what we did with that whole new script is do whatever this for loop did. And it might seem a little weird that we just duplicated code. Well, I'm going to delete it, but it might be weird that we could have just used that for loop and it would be fine. But what I'm trying to do is set up the code so it's a better architecture to work with. And this will just have be a lot easier to work with a separate script, because in the future we're going to want to listen to events when player dies and when the game is over. We want to switch where we're looking, so it's just going to be a lot easier to have this separated. So let's see if this works by doing that. Okay, so it seems like it works. One thing I'm noticing is the camera is slightly offsetted. It has to move a little bit before it starts. That we can solve actually just by jumping over to the camera follow script. I think it'd be better to, when we set this target, to jump to the position that we want. And actually we'll maybe make it an option to do that, but we'll do a public void set target and transform target, and then we'll just give the option, do you want to snap to the position of the target right away? So that should be good. So we'll just call it snap to target. Maybe I'll change that in the future. And basically we want to set our target to the passed in target, And if we're snapping to the target, we want to set the position directly. And actually, I'm going to copy this. And I could just have it duplicated twice, but I'm actually going to reset that a little bit. But I'm going to create another function here to basically prevent duplicating this code, and call it get target position. And all we want to do is just return this. And I'm going to call it here. Whenever you have duplicate code like that, it's nice because I'm going to call this again, and it's nice just to have it in one function, not written twice. So if snap to target, we just want to set transform to position equals get target position. And that should be good like that. And so now here's the question of if we want this target to be public for players. I'm going to maybe just set it to private just for right now, because we want to encourage users and developers to use this function. So I think it's better just to have this private for now, and possibly make it public back in the future if you want to change in the editor. Okay, so let's see if this is going to work. Okay, so now this is telling us that we want that we need to change it since target is private. We can't just change it directly. So now we have to use that function that we created. So set target, and we just want to pass in target object. And we want to, the whole point of this was just to snap to the initial position right away. So I'm going to say, yes, snap to target. And let's see if this will work. Okay, so yeah, it looks like it's actually jumping right to the player at the beginning, not slowly updating to that. So that's something that we're looking to do, and that looks great. Let's see if there's anything else with this camera movement. I think as it is, it's how we want. Obviously, we're going to have additional changes to the future. Specifically when the game is over, we want to change the target transform, but for right now, it does look pretty good. It follows the player, and I think that'll work good for our use case right now. The next video is actually something that I just did right now. Is I want players to die whenever they get into a zone that we call a death zone, so they don't get trapped like this player right here. So we want this whole kind of respawn script and this whole flow of creating the player. And that's something that we're going to be doing in next video, is actually getting the player to respawn, to die, and then later on in future videos we'll do the weapons and power-ups. But that's good. So that's where I'll leave it for now. We got the camera movement implemented, and yeah, I'll see you in the next video.